Hello my dear children, once again welcome to our physics class. In the previous session we had discussed about dimensions, dimensional equations. Okay, we learned how we can represent different physical quantities in terms of its dimensional formula. Today we will study the last topic of this chapter, that is applications of dimensional analysis. We had learned about this dimensions, dimensional formula, everything. So what is the use or where do we apply this dimensional analysis? So the first application is check the correctness or consistency of equation. The dimensional analysis helps us to check whether an equation is correct or not. And the second application is this dimensional analysis helps us to deduce the relation between different physical quantities. So we can do some examples based on these two applications so that the concepts will be much more clear to you. Okay. So first application is check the correctness of equation. Suppose you have given an equation like this, v is equal to u plus at. And you are familiar with this equation. This is our first equation of motion. You have learned this equation in your class 9 physics. You need to check the correctness of equation. So how do we apply dimensional analysis to check the correctness of the equation? For that, you need to find out the dimensional form of each term in this equation. On the LHS we have velocity v. On the RHS we have velocity u, also acceleration acceleration a and time t. So we need to find out the dimensions of each term of this equation. So let's start. First term is v. V means what? Velocity, and we have already studied the dimensional form of or formula for velocity. What was that? It is m raised to 0 L t raised to minus 1. Okay, so this is the dimension of velocity. Next term is u. U again it's a velocity, so its dimensional term will be same, m raised to 0 L raised to 1 t raised to minus 1, because both express the same thing, that is velocity. And next is acceleration, a into t. Okay, so first we need to write the dimension of acceleration. What is the dimension of acceleration? M raised to 0 L t raised to minus 2. This is the dimension for acceleration. Then what is the dimension for time? Dimension for next term is t, time. So dimension for time is t. Next, just multiply, equal to m raised to 0 L raised to 1. Then we have t raised to minus 2 into t. T raised to minus 2 into t. Here the power of t is 1. Here the power of t is minus 2. So minus 2 plus 1, that is minus 1. So t raised to minus 1. So this is the dimension of at. This is the dimension of u. This is the dimension of v. Just look at the dimensional form of each term. Is it same? Yes. That means this equation is correct. So this is known as consistency of equation. And this is known as the principle of homogeneity. The dimensional form of each term in this equation is same. That means the equation is consistent. Okay, and this principle is known as principle of homogeneity. Okay, so how will you apply dimensional analysis to check the correctness of equation? Just find out the dimensions of each term in this equation. If all the dimensional equations are correct or same, then the equation will be dimensionally correct. Okay. Next we can take another example. Consider this equation, half mv square equal to mgh. So just check whether the equation is dimensionally correct or not. So how will you check? First you need to find out the dimensions of half mv square. Okay, so half is a constant. It is dimensionless. Constants don't have any dimension, so half is dimensionless. No need to care that. No need to consider that half. Then next is mass. What is the dimension of mass? It is m. Next is velocity. V is velocity. What is the dimension of velocity? It is L t raised to minus 1. And since it is v square, we need to add a square here. Okay. So this is the dimension of half mv square. Now just write it. So you will get m. Make it together. M L square t raised to minus 1 into 2 is minus 2. If you want, you can write m here, no problem. Okay. So again, even if you write m here, you will get the same one. Here the power of m is 1, here the power of m is 0. So m into m, 1 plus 0, 1. Power of m will be this, 1 itself. So this is the dimension for half mv square. Now next find out the dimension of mgh. What is the dimension of mgh? What is the dimension of m? Mass, it is m. And what is the dimension of g? What is g? G is acceleration due to gravity. And even if it is acceleration due to gravity or acceleration, the dimension will be same. And what is the dimension of acceleration? It is m raised to 0, L t raised to minus 2. Then what is the next one? Height. Height means it is expressed in meter or centimeter. So its dimension will be L. Okay. Now multiply all the terms. So m into m. Here power is 1, here power is 0. So 1 plus 0, 1. M raised to 1. Next. L. Here we have L. Here we have L. L into L. L square. Next. T raised to minus 2. So this is the dimension of mgh. M L square T raised to minus 2. And this is the dimension of half mv square. Half m L square T raised to minus 2. So both are same. That means this equation is dimensionally correct. So like this we can apply dimensional analysis to check the consistency of equation or to check the correctness of the equation. We can only say that this equation is dimensionally correct or not using this technique. Okay children. Now let's discuss the second method.